Diary, hello. It is February the 16th, 2022, and today we are going to look at the floppy disk boot of my 40-year-old or thereabouts Cromemco Z2 computer system. So first of all, I'm going to introduce you to the SD card. Let's see if I can get my presenter video screen on board so I can see what I'm doing. So yes, this is the SD card we're going to be using. The Cromemco system is just behind you, just there. And the first thing to know is that this is using a floppy disk emulator. So whilst this Cromemco system can support 4 floppy disk drives, we actually have 2 physical floppy disk drives. One is the equivalent of an 8-inch floppy disk drive, and one is a genuine 360K 5¼ disk drive. And the other 2 disk drives are simulated, and they're simulated via something wonderful called the H for Hotel XC floppy disk emulator. And that takes an SD card, and on that SD card, which you see before you, are a number of disks. So let's look at that. That's the contents of the SD card, and we're going to be booting off disk number 693, which this is a DOS format disk, so I've only got 8 characters to play with, so I can see to me that my numbering convention is disk number 693 and then C168, which I know to mean Cromix 168, as opposed to disk 524, which has got Cromix 172 for the XU processor. So we're going to be booting a Cromemco system with a 68010 processor card, but it's actually a dual processor. It's got a Z80 processor and a Motorola 68000 style processor. So when the system starts off, it always starts off in Z80 mode. So let's put this SD card in, and then we're going to take it from there. So if I'm lucky, okay, yeah. So since that was the card I was last using, the HXC emulator will go to that same card. So the next thing I need to do is to power on the Z2 system and press the reset button. So let's do that. So now we've reset the computer, and it's in such a mode that it's about to start, but it won't actually start until it gets a serial connection to me. Now I've already started a putty session on COM11, so from this workstation computer is a USB connection, and that goes into a USB to serial converter, and out of that serial converter is a serial cable, and I've set my end to be running at 9600 baud. Now when I press the return key, we hope to see this memory test. I'm going to press escape, and we've stopped the memory test so I can talk to you. So when a Cromemco computer starts off, on most Cromemco computers, the floppy disk controller contains a ROM which is loaded to 0x3C000. So it's at C hex C000 in the first 64K memory space, and the processor automatically jumps to that location, and it jumps to the location using the Z80 processor. So what you saw in front of you was Z80 code that had been executed to automatically do a memory test, and that memory test was showing me that it could get to the first 32K of memory here, and it couldn't find the last 32K of memory. That's because when the system starts off, it has to have the bottom 32K of RAM memory enabled and the top 32K of the 64K disabled, so that the ROM on the floppy disk controller can be seen and used. So the ROM is available starting from C00. That is what is powering this initial display. So when you hit enter, the actual initial Z80 code looks for a carriage return, and the more times you press the carriage return key, it compares the processor goes through a tight loop trying to figure out, am I getting a carriage return? Based on what it can see, it sets the baud, it tries different baud rates until it gets a carriage return, in which case it knows what the baud rate is. There is an option to set, I think, on some of the DIP switches, on some versions of RDOS, the Resident Disk Operating System, there's an option to set a specific baud rate, in which case it wouldn't need to do that and it could go straight into the booting process. But that's not been set here, so I've got extra flexibility and extra time for the boot. Anyway, so what I thought I'd do first of all, I can just use the B command to boot to the A drive, but I thought I'd just test the diskette first. Now, as you saw, this is actually a single file called, in this case, 693c168.hfe, and that's going to be emulating an 8-inch floppy disk. So that's got 77 tracks and 2 sides. And this is going to have the most possible information on it, so it's actually in double density format. So you get about just over 1 megabyte of information, and that was enough for a Cromemco system to boot, and not only just boot, but boot in a kind of Unix style operating system. So we're going to run the T command first and test out that floppy disk. So T for test. First of all, it's doing a memory test in 4K blocks. You'll see all those up arrows mean to say that it's not only found the memory but tested it successfully. Next it says, what have you got? Have you got a floppy or a hard disk? I've got a floppy disk. It's drive A, and it's a large drive, and it's a slow seeking drive because the fast seeking drives were per SI drives, which were used originally for Cromemco computers, but they're also, although they were very performant and had better performance than the regular drives, they were extremely expensive and didn't age very well. So they were kind of dropped towards the end of the Cromemco dynasty. So we say slow, that's what it is. I'm going to press escape to abort. I don't want to write onto that disk unnecessarily. Now the sounds you heard were actually the HXC floppy disk emulator emulating the sound of a floppy disk. There's no actual floppy disk, there's no moving parts from the perspective of the floppy disk actually for drive A, but it sounded like there was, and when I do a boot command in a second you'll hear more sounds, but that's all synthesized. But it is very comforting because the sound of a Cromemco Cromix boot is something that I grew up with, and I can actually tell what it's doing, so it's bizarre. Right, here we go. We're going to do B, and then for B for boot, and we're going to do A for boot to drive A. So let's go. And don't forget, right now we're in Z80 mode. Okay, so now we're getting a printout of a memory test in 16K blocks, and you'll see that the addresses look quite long, and you can see that that is more than a 16-bit address. So this is the 68,000 processor speaking back to us, and it's testing by 16K blocks. Now all this is coming from the operating system file Cromix.sys, and it's already read that from the floppy drive, and that's what contains the memory test. Now when you configure Cromix, you can tell it how much memory is available to the system, and so it doesn't dynamically find that out. And as you can see here, I've configured an amount of memory, and the pluses means to say that it's found that memory, and the minuses means to say that it didn't find the rest of it. So you can set a bigger memory size than is there, and it'll test up to the total amount of memory in 16K blocks. Okay, it's done the memory test. The next thing is it actually has to boot. Now again, this is a configuration situation because when you configure the operating system, you can tell it to always boot from the floppy drive or always boot from the hard disk controller. So you can say get the boot files from the floppy, which we've just booted from, but then boot onto the hard drive. It's quite flexible. Or you could say boot automatically onto the floppy, but you might want the choice. So this is if you don't specifically put the major and minor number, as we say in Unix terms, it's going to ask you. So it's floppy, it's major device number 1, and it's the A drive, so that's FDA is the 8-inch drive. SFDA would be the 360K 5¼ inch drive. So we're going to say 0 and booted. So when I generated the operating system last year, I generated, you can generate a sort of title, so that's for my own benefit. So I know that that's version 168 of the operating system, and I generated it with tape, hard drive, and ESDI hard drive, and multiple serial port octart drivers. Now you see there's an error message here, and that's because although the system contains an STDC hard drive controller, there's no hard drive switched on. So we got that error message where it tried to just reset the hard drive heads, didn't get anywhere because there's no hard drive. Okay, we have in fact booted. Congratulations. Let's do a ls-l of the root directory. These are all the files. Now normally you could have your boot disk in drive A, and for example you could have all your applications and data on, say, drive B or drive C or D. In this case, since I would normally use a hard drive system, I only ever boot off the floppy for diagnostic purposes or to generate a new hard disk system. So a floppy drive is just a means to an end of generating a hard drive system. Okay, so we're done really. I just want to shut down in a nice way. We've done a quick list of the root directory. You'll see that nothing is mounted apart from this floppy drive itself. Yeah, so the root file system is mounted. That's it. Let's do a ps-el to list what processes are running. And the formal way to shut down a Cromemco system is to do a kill -2 So we send signal 2 to process 1, and the result is shut down. Okay, so as I said in the previous video for the hard drive system, in the early days of Unix, one would never be so stupid as to just power off the machine. You absolutely must shut the machine down properly so that it writes all the unwritten buffers to disk and quests everything very nicely. Otherwise you run the risk of not being able to restart your system because just a straight power off might leave the disks in an unrecoverable state. So always make sure to run the kill command to shut the system down. I think we're done. Thanks for watching.